All right, welcome to the video on solving polynomial equations. So as you're going to see here, we're solving polynomial equations. So this first question that is given to us here is, how do you find the zeros of the polynomial function f of x equals x cubed minus x squared plus 13x plus 75? So if you look at this, the degree is 3, which everything that we've done so far is we say the only possible way that we know how to solve it right now is by factoring it. If it has 4 terms, we try to factor it by grouping. If I try to factor this by grouping, there's a GCF of x squared, and I have x minus 1. And then when I group these two together, there is no GCF. It doesn't factor to something times x minus 1. So this is not factorable by grouping, okay? So we need another method. So here is our other method that we're going to learn. Okay, what we're going to do is we're going to learn the rational zero test. Okay, so when given a polynomial function in standard form, and here's your standard form written right here, okay, we can find possible zeros. We can generate a list, basically. So to find those possible zeros, what you're going to do is you're going to use what's called a P over Q list. P is the factors of the constant, so that's A naught, or we call it P also. And Q are the factors of the leading coefficient. So what you're going to do is you are going to do the factors of the constant divided by the factors of the leading coefficient, and all of those are possible zeros. You test them using synthetic division until you find ones that work, okay? So it's a process, right? But we're going to try some. Okay. All right. So in order to see what this is like, what we're going to do is we're going to try try a few problems here. So step number 1 is if a 0 is not given to you, which sometimes it'll be like, and this is a 0, and then you can start with that, but no zeros are given to me here. So what we're going to do is we're going to generate this possible list of zeros. So how we do that is we take factors of the constant. So I need factors of 75. So 1 and 75. Right, so I'll start with plus or minus 1, because positive 1 and negative 1 also work, right? 2 isn't, 3 is, plus or minus 3, 3 and 25. And I'm going to put those on the end because I like writing them in numerical order. It's just nothing. 4 is not, 5 is, 5 and 15. And then nothing else other than those other 3 that I said. So we have 15 pairs up with the 5, and then that was 25 and 75. So if you look, there is a list right there of my factors of my constant. Now I'm going to find the factors of my leading coefficient. My leading coefficient is 1, so my factors are plus or minus 1. So now what I'm going to do is I'm going to divide each of my p values by each of my q values. So I'm going to divide this by this, 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 and this by this. But notice I'm dividing by positive 1 and negative 1, so I'm just going to get the same list that I have. So I'm just going to copy and paste that, because why would I write it again, right? Okay. All right, so now what we're going to do is we're going to use synthetic division to test to see if these are zeros. Okay, so I'm going to first look and see that I have cube, square, first power constant, so nothing's being skipped, and then I will write that. So 1, negative 1, 13, and 75. Okay, so I'm going to start by picking one of these numbers, any of these 12 numbers right here. I'm going to start with 1, right? And I'm going to see if it gives me a remainder of 0. If it is, it's a factor, okay? I also know that I only need to find 1 0, because if I can find 1 0, then I'll get it down to a quadratic, and I know how to solve any quadratic, right? That was what we used in previous chapters. Like, we know how to solve any quadratic. So that's what I'm going to do. All right, so drop your 1. Multiply, you get 1. Add, you get 0. Multiply, you get 1. Add, you get 14. Multiply, you get 14. And add, you do not get 0. So, out. I'm going to take that 0 away there so I don't confuse myself at any point. All right, so now you can either switch to negative 1 or move on to 3. It doesn't matter. So let's say I switch to negative 1. Drop my 1. Multiply, I get negative 1. Add, I get negative 2. multiply, I get 2, add, I get 15, multiply, I get negative 15, and that, once again, is not 0. So erase, or like if you're working on paper, you can just move it again, right? Or you can erase. It's up to you, right? All right, I'm at 3. So 3, drop that, that's a 1, multiply, that's 3, 2, 6, 19. 19 times 3 is not negative 75, so no. I'll try negative 3. 1 times negative 3 is negative 3. Adding, I get negative 4. Multiplying, I get 12. Here we go. Adding, I get 25. Multiplying, I get negative 75. Adding, I get 0. Fantastico. Okay, so now I know that negative 3 is a 0. So that is one of my solutions. Okay, so it says, once you find a 0, try to factor and solve the remaining because you have a quadratic left. So let's write what we have. We have this so far factored into f of x is equal to negative 3 is a 0, so x plus 3 is a factor. And then remember, this is my quadratic that I have left. So x squared minus 4x plus 25. So now I'm going to see if this is factorable. And I don't have to keep testing these because I know how to solve that without using this method, right? So two numbers that multiply to give me 25 and add to give me negative 4, not going to happen. But that doesn't mean I can't solve it. So now, in order to solve that, I have to use either completing the square or quadratic formula. Since my lead coefficient on this quadratic is 1 and the middle term is even, I'm going to complete the square. So I'm going to do x squared minus 4x, subtract 25 from both sides, is equal to 25. Take half of b, which is negative 2, and square it. So that's plus 4 plus 4. I already see that I'm going to get imaginary solutions, but the directions change. Like sometimes it'll say real solutions, sometimes it'll say complex solutions, sometimes it'll say rational solutions. So you just have to pay attention. I haven't paid attention, so I'm just going to keep going. Square root plus or minus. So I have x minus 2 is equal to plus or minus I root 21. And then add 2 to both sides. So I have 2 plus or minus I root 21. Okay, so now I have my 3 solutions. X equals negative 3, and x equals 2 plus I root 21, and x equals 2 minus I root 21. Now look at the directions. What does it ask me for? If it asks me for real or rational, it's just this. But if it asks me for just solutions, I have to give them all. If it asks me for complex solutions, I have to give them all. So let's see. Once you find a 0, try to factor and solve the remaining quadratic equations. Oh, that's all it says. It says solve. It doesn't say real zeros, or it doesn't give me directions, right? So I have 3 solutions, and there they are. Okay? All right. And this is my factored form because it does ask me for my factored form too. It's as completely as factors as it's going to get. All right, so let's try some more. So it says make a list of the possible zeros. So we're going to generate our P over Q list because once again, I wasn't given any zeros. So my P list, my factors of P are plus or minus, I'm looking at 15 here, so 1, not 2, but 3, not 4, but 5 and 15. And don't forget your plus or minus. And then for Q, I have my lead coefficient is 1, so that's plus or minus 1 and plus or minus 2, okay? So I have to divide, once again, to get my P over Q list, I have to divide all of these by 1, which that's just generating the list, right? Dare you. All right, so we have plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. And then I also have to divide all of them by 2. So I have to divide this by 2, so that's plus or minus a half. Divide the next one by 2, so that's plus or minus 3 halves. Plus or minus 5 halves, and plus or minus 15 halves. So this is kind of because I have, 16 possible rational zeros, right? I have 16 possible zeros that I have to test until I find it. This is a third degree polynomial, so either one of these works or three of them work, right? Because I can have one real and two imaginaries, or three reals, right? So we're hoping, or I could have none of them work and they all be imaginary, or not imaginary, I'm sorry, irrational, or one irrational and two imaginaries, but that's not going to happen. Okay, so let's start testing. I'm talking too much. All right, so I'm going to write my coefficients. I have nothing missing, no missing terms. So I have 2, 3, negative 32, and 15. I think this is one of the most important parts, is writing out those numbers correctly. Because if you test 16 numbers incorrectly, you just wasted a bunch of time. All right, so I'm going to start with 1. I'm going to drop the 1, drop the 2. There is no 1 to drop. Drop the 2, multiply, that's 2. Add, that's 5. Multiply, that's 5. Add, that is negative 27. Multiply, that's negative 27. I'm going to stop there because that's not 0. All right, I'll move on to negative 1 now. Drop the 2, multiply, it's negative 2. Add, that's 1. Multiply, that's negative 1. Add, that's negative 33. Multiply, that's 33, which doesn't give me 0, so I'm going to stop there. And I'm going to move on to positive 3. Drop the 2, multiply, that's 6. Add, that's 9. Multiply, that's 27. Add, that's negative 5. Multiply, this is good, negative 15, and I get 0. All right. Okay, so find the solutions over the real numbers. So I don't want any imaginary solutions for these directions. And then also write it in factored form. All right, so I have f of x equals, so far I have x minus 3 as a factor because 3 is a 0. I could also put x equals 3 is a 0 here. And then my other factor thus far is 2x squared plus 9x minus 5. And now I have to see if that is factorable. All right, so I'm going to try to factor that. I'm going to use my organizational x, but you can use guess and check if you want. Two numbers that multiply to give me negative 10 and add to give me 9 are 10 and negative 1. Divide by that lead coefficient, which is 2. Simplify your fraction, which is 1/5. So I can see that this factors 2. I'm going to just write it on my factored form line here. F of x equals, do not forget the x minus 3. And then that's x plus 5 and 2x minus 1. All right, now to get my other two zeros, I'm going to set each of these factors. I'll just use my highlighter here so I don't have to erase. This and this equal to 0 and solve. So if I set x plus 5 equal to 0 and solve, I get x equals negative 5. And if I set 2x minus 1 equal to 0 and solve, I get x equals positive 1/2. And those are all real zeros. Okay, we get the gist, right? I love this. Isn't it fun? Okay, I might get ridiculed for that. All right, so I need to do my P over Q list. I need factors of 28 divided by factors of 1. Since Q is factors of 1, I'm just going to write my P over Q list as my factors of 28, right? So I have plus or minus 1, plus or minus 2 goes in there. 3 doesn't, but 4 does. 5 doesn't, 6 doesn't, but 7 does. So now I'm at like the matchup stage, right? So I can just think of it that way. 14 does, and 28 does. All right, so I have a list of 12 things I need to check. Let's hope it starts soon, okay? So I'm gonna start with 1. And if I look at this one, this is a 4th degree polynomial. So I have 4 possible that work here, right? So I'm going to start with making my L, okay? And I have 1, negative 6, so 4, 3, 2, 1, 0. Okay, good. This is the weirdest font I've ever seen. That 3 is ginormous, but I'm not going to judge it, apparently. 3, 24, negative 28. All right, so I'll start with 1 like I always do. Drop the 1, multiply, I get 1, add, I get -5, multiply, I get -5, add, I get -2, multiply, I get -2, add, I get 22, multiply, I get 22, no. Wah, wah, wah. All right, I'm gonna try 2 next. Okay, here we go. Drop the 1, multiply, that's 2. Usually I try -1. It's okay. Multiply, that's 2. Add, that's -4. Multiply, that's -8. Add, that is -5. Multiply, that's -10. Ooh, good news. That's 14, 28, 0. Yay. Okay, so now remember what we talked about yesterday is that when you're doing synthetic division, we've got it broken down now to f of x equals x minus 2 times x cubed minus 4x squared minus 5x plus 14. So I have it broken down. I'm going to continue off of that polynomial. You can write it separately here and do 1, -4, -5, 14, and start over here, or you can just continue off of this one, which is what I'm going to do. I'll switch colors to distinguish that I'm like switching here. But once again, I'm trying to get 0 as my remainder. All right, so you could test 2 again, because 2 could be a repeated factor, right? 2 could be a repeated factor. I know I'm not going to test 1. I could test -1 next if I wanted to. I could test 2 again. I could move on to 4. I can test -2. I have the answer key in front of me, so for the sake of the time in the video, I'm going to test -2. Wink, wink, nudge, nudge. All right, drop your 1, multiply, -2. Add, I get -6. Multiply, I get 12. Add, I get 7. Multiply, I get -14. Add, I get 0. Shocking, I know. I'm amazing. Okay, so now I have, so far, I haven't written down my zeros, but I have x equals 2, x equals -2, right? And then I have 2 factors so far. I have 3 factors so far, sorry. I have, it doesn't say f of x, so does this even ask me for factored form? It does. I have 2 factors so far. I don't have to put f of x equals because it's not called f of x. So I have x minus 2 from my first 0, x plus 2 from my second 0, and then my third factor I have right now is, remember, it started off as a 4th power. And then I got it down to a cubic, and now this is a quadratic. So this is x squared minus 6x plus 7. 6x plus 7. Okay, so now I have to see if this is factorable so that I can factor that. So I'm looking for 2 numbers that multiply to give me +7 and add to give me -6. Which is not going to happen. 7 and 1 give me 8, and I can't make one of them negative, and -7 and -1 give me -8. So that's not going to happen. So this is my completely factored form. So I'm going to go ahead and copy and paste this. I can't factor that quadratic. No, I want, boo. Okay, I want to copy and paste this. Copy, paste, and don't forget your equals 0. Because we are factoring this. Oops, not with that 2. We're factoring this, okay? And I need to find my other 2 zeros, right? Does it say real numbers? And they could be real, right? They don't necessarily have to be imaginary. They can just be ugly answers. And when I say ugly, I mean having radicals in them. All right, so let's solve this. X squared, I'm going to use completing the square again. Minus 6x, subtract 7 from both sides is -7. Take half of b, which is -3, and square it, which is 9. Ooh la la, I'm going to get 2 more real answers. Factor this, x minus 3 quantity squared equals 2. Square root to solve, plus or minus. X minus 3 equals plus or minus root 2, and then add 3 to both sides, 3 plus or minus root 2, which are real solutions. So I am including them based on the directions. X equals 3 plus or minus root 2. Remember, imaginary solutions have I in them, so these are real numbers. They're just not rational, they're irrational, which is fine. Okay, probably feeling pretty good about this, right? All right, so now we have another cubic function. Let's list our possible rationals. So I need factors of 3 divided by factors of 2. So I have factors of 3, which are 1 and 3. And then I need to divide them by factors of 2, which are 1 and 2. So I need to divide both of those by 1, and I get those. And then I need to divide both of those by 2, which I get plus or minus a half and plus or minus 3/2. La la. Okay, so my coefficients are 2, 3, -8, and 3. Okay, and I'm going to start with trying 1. Drop it, that's 2. Multiply, that's 2. Add, that's 5. Multiply, that's 5. Add, that's -3. Multiply, that's -3. Add, that's 0. All right, so that's down to a quadratic, so I can stop with this, which is awesome. So my factored form thus far is f of x equals x minus 1 times 2x squared plus 5x minus 3. And now I'm going to see if this is still factorable right here. So I need two numbers. I need two numbers that multiply, yep, it's factorable, to give me -6 and add to give me 5. So that is -3 and -2, right? -3 times negative, no, it's not. No, it's not. Wrong. It is +6 and -1. +6 and -1. That multiplies to give me -6 and adds to give me 5. Good. Divide by our lead coefficient of 2. Simplify this fraction 3/1. And now I can write my factors. So I'll write it on the factored form line. F of x equals x minus 1. Don't forget that x minus 1. And then we have x plus 3 and 2x minus 1. And now I can get my zeros also. X equals 1, the one that I already had, but also by setting x minus 1 equal to 0. X equals -3, and x equals a half. Okay, was that f of x equals? No, it wasn't. So let me get that f of x equals out there. Excuse me, and put equals 0. And I need to fix that because it looks like there's a negative hanging out in front. Okay. All right. 2 more. Okay, so factors of p are plus or minus 1, plus or minus 2, and plus or minus 4. Factors of 1 are plus or minus 1. So there is my p over q list. I'm going to write down my coefficients. A cubic is missing. So I have 0 x cubes. So we have 1, 0, -13, 20, and -4. My -4 disappeared. All right, I'll try 1. Drop this, multiply that's, or sorry, drop that, multiply its 1, add its 1. Multiply its 1, add its -12. Multiply its -12, add its 8. Multiply its 8, add its not 0. Erase, erase, erase. All right, I'm gonna move on to 2. Drop that, it's 1. Multiply, that's 2. Add its 2. Multiply its 4, add its -9, multiply its -18, add its 2, multiply its 4, add its 0. Fabulous. All right, I'm going to continue off of this polynomial. Okay, and I can try 2 again, or I can try -1 or -2 or 4 or -4. I'm going to try 2 again. All right, drop its 1. Watch, it doesn't work this time, or it doesn't work even though I'm going to try it. 1 times 2 is 2. Add its 4. Yeah. 2 times 4 is 8. Add, it's negative 1. Multiply, it's negative 2. Add, it's 0. My luck. It's so good. I know I said an answer key in front of me, but I didn't look at it. Okay, so 2 is a 0 twice. We list it once. We are going to write it as a factor twice. So we have f of x equals x minus 2 is a factor. It repeats, so I'm going to put squared. And then I have my other factor, which is this quadratic x squared minus 4x minus 1, which is not factorable. So I'm going to complete the square. But this right here is my factored form because x squared minus 4x is not factorable. This was equal to 0. So I'm going to hit copy, paste, equals 0. There's my factored form. And I'm going to find my other 2 zeros by completing the square because I don't know right now if they are real or imaginary. So x squared, it says find the solutions over the real numbers. Okay. Minus 4x, add 1 to both sides, so equals 1. Half of b is negative 2, squared is 4, so I'm going to add 4 to both sides. They are real solutions. X minus 2 quantity squared is equal to 5. Square root to solve. If this was a negative number, then I would I would definitely stop right there because the directions tell me real. X minus 2 is equal to plus or minus root 5, and then add 2 to both sides. So my other 2 real solutions are x equals 2 plus root 5 and 2 minus root 5. Good. Okay, is this the last one? Sure is. Find all the real zeros given that we know 2 is a 0. What a gift. It gave me one of the zeros. So notice it doesn't give me directions on make the P over Q list, and that's because I'm going to have to do it on my own once I am, air quote, stuck, okay? Because I know that I'm going to get stuck because this is a 4th degree polynomial. It's only going to bring me down to a cubic function, and then it's like, all right, well, I need the rest of my zeros. Okay, so I'm going to start with 2 is a 0. All right, so I know that this is going to give me a remainder of 0, and if it doesn't, I made a mistake. All right, coefficients, look at my x1 is 4, 3, 2, 1, 0, I'm good. All right, so 1 on the x to the 4th, 1 on the x cubed, negative 10 on the x squared, negative 4 on the x, and then 24 is my constant. All right, drop my 1, multiply that's 2, add that's 3, multiply that's 6, add that's negative 4, multiply that's negative 8, add that's negative 12, multiply that's negative 24, add that's 0. All right, fabulosity. Okay, so now I know one of my solutions is negative 2, but they already gave me that. I'm not going to repeat it. Find all the real zeros given that we know x equals 2 is a 0. So I don't have to list that one. So find the others. And on your test, it'll say find the other zeros. So I'm not going to list 2 already. Okay. All right, so now what I'm going to do is I'm going to continue off of this, and I need to try other zeros, but I don't have a list. So what I want to do is I want to generate a list. So far I have it factored to P of x equals x minus 2 times x cubed, where am I? X cubed plus x squared minus 4x minus 12. So I need to solve this, and there's actually 2 ways to solve this, and I'm going to first use the way that we just have been using, and then I'll come back and be like, could have done that. Okay, so I'm going to say that I forgot things I've learned in the past, and okay, let me actually say I'm not going to forget. I should next try factoring this by grouping, which it is not factorable by grouping, okay? Or is it? It is. What I wrote down is not, but there's a 3 right here. So what I was looking at is that it's not factorable by grouping. This is factorable by grouping. So I should stop and factor it by grouping and do it that way, because that is knowledge that I have, okay? But what happens if it's not factorable by grouping? You have to continue on using your P over Q list. And that can happen to you, wink, wink, nudge, nudge. So I'm going to continue with that and then say, oh yeah, I could have just factored by grouping after I'm done. Okay, so P over Q list. I have to find zeros for this. I'm not gonna start from the beginning and use 24 because that's a waste of my time. So I'm gonna do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay, so I'm going to check to see if 2 is a repeated 0 first, and then I'll go back to the beginning of the list because I hate skipping over that and then realizing, oh no, that's what it was. All right, drop my 1, multiply its 2, add its 5, multiply its 10, add its 6, multiply its 12, add its 0, and thank goodness I didn't. Okay, so now this is going to factor to P of x is equal to x minus 2 times x minus 2, which is x minus 2 squared, times x squared plus 5x plus 6. And now I can factor that. So I have P of x equals x minus 2 squared, and then that factors to x plus 3 times x plus 2. And so there's my completely factored form, and now I can find all the zeros. So we already listed 2. We're not going to list it again, but we're going to list x equals -3 and x equals -2. And those are my other 2 zeros. Okay, so once again, if you didn't catch what I was saying because I was babbling too much, this right here, I could have stopped and said, let me factor that by grouping. I'm going to group the first 2 together. They have an x squared in common, and then that's x plus 3. Group the second 2 together. They have a -4 in common, and that's x plus 3. So this factors to x plus 3 times x squared minus 4, which that factors to x plus 2 times x minus 2, and then you could say x equals -3, x equals -2, and x equals 2, along with x equals 2 right here. See that? Okay, but that doesn't always become factorable by grouping. You have to know this way also. All right, so this was it completely factored, and these are the remaining zeros. All right, last but certainly not least, it says, now solve the inequality. This inequality is equal to 0. So I have to factor it, and then I have to find the zeros, and then I have to put them on a number line, and then I have to test points. But guess what? We did most of that. We already factored it up here, right? It's already factored right there. So I just have to set each factor equal to 0 and put those on a number line, which I already got my zeros also. They're 2, -3, and -2. So I'm going to put -3 here, -2 here, and 2 here. I am not including any of these because it's where it's greater than 0. I'm going to pick a point anywhere to test. I'll do x equals 0. And if I plug 0 into the factored form, I get a positive times a positive times a positive, which is positive. And then I'm going to do the shortcut method. So as I cross over 2, that comes from the factor of x minus 2, which is even, so I'm going to keep the sign. As I cross over the -2, that comes the factor of x plus 2, which is odd, so I'm going to change the sign. And that factor is also odd, so I'll change the sign. So where is it greater than 0? Here, here, and here, which is -infinity to -3 union, -2 to +2 union 2 to infinity. All right, that is our lesson for today. It was a long one, but hopefully full of knowledge. All right, get